Hi, question number 2. Distinguish between the distance and displacement. So as you know, the distance is referred to the scalar quantity, right? This scalar quantity, and the displacement is a vector quantity, right? So meaning if the distance scalar quantity must have a only magnitude, and the vector quantity for the displacement must have magnitudes and direction. Or we can distinguish between distance and displacement the distance is the actual distance between the 2 points. Let's say you have a point A and point P. The distance here is you must measure the distance from A to B. But if you look at the displacement, the same process from A to P. So the distance displacement is a distance between 2 points in the straight line, and let's say you have the motion is A to B and back to the A, so the displacement is equal to 0. But if you look at the distance from A to B and back to the A, the distance is a actual distance traveled. So meaning here the first part is 10 meter, and the second part back to the A 10 meter. So meaning the distance is a 20 meter. But for the displacement from A to B is 10 meter, and then back to the B to A is 10 meter, because the direction B to A is a negative, so meaning the displacement is equal to 0. This is how you can distinguish between the distance and displacement. So number B. Figure 1 show a stone. Let's say this is the stone is thrown horizontal. This is direction of the stone horizontal with the initial u 40 meter per second from the top of 17th high building. This is for initial positions of the object, and throw horizontal at the position to 17 meter. Sketch the path transversed by the stone to the ground and indicate the velocity component resultant velocity stone 50 meter from the ground. Okay, so after the stone thrown horizontal, the path of the stone is like this. So we have this is straight line, right? This is straight line, and after that we have a look at the like projectile motion or semi-projectile motion. So let's say this is a position at the 15 meter from the ground, right? So now here we have a direction of the V. Sorry, this is direction of the V here, V, and this is direction of the this of V here to the Vx, and here we have a Vy. This is how you can sketch the horizontal Vx and vertical velocity for Vy, and this is resultant for the V. Okay, next question, number 2. Calculate resultant velocity of the stone 50 meter from the ground. So now if you calculate what is the velocity here. So to calculate the velocity here, if I can draw the diagram here, so we have a V, this is resultant V, and we have this is Vx, then resolve V here to the x-axis, and here we have a Vy, so this is Vy. So now to find the value of the v here, you can use the value of the vx here, and you can use the vy here. So let's say this is a vy here. So meaning is I draw the diagram here. So we have a vx, we have a vy, and now what is the value of the v here? So can use the triangle here or Pythagoras here, or can use the concept of trigonometry to calculate the value of y. But to find the value of the f here, first you must know the value of the vx here. Because of the vx, this is ux, right? Sorry. Okay, to calculate the v here, so we can must find the value of the vx, because the vx 40 meter per second is always constant at any point, meaning that any point here, the v is constant 40 meter per second. So the v here also 40 meter per second. The problem is what is the value of the vy. So the vy here, you can use the equation vy square, is equal to uy square minus 2gs, because the uy here is equal to 0. Y is equal to 0 because the initial direction for the stone only for direction on the x or horizontal x, no direction for the vertical or uy, so meaning uy is equal to 0. So to calculate the vy's here, so we have a negative 2gs here, and vy here we have a negative 2, because g here, the g here is a 9.81, and the s or displacement here is a, because this is 17, because the here we have a at the position 15 meter, so meaning here the another displacement or s here is a 55, right? 55 meter. So here s is equal to 55 meter. This is because direction is downward, we have a negative. So this is the value of the v. You can find the value of the vy, right? So to calculate the value of the v here, so we can use the v is equal to square root vy square plus vx square, and the next vy square, you can use the answer here, the final answer for the vy, and for the vx we have a 40. So meaning you can find the value of the v here if you get the answer. So meaning you can use your own calculator to find the v here, 51.73 meter per second, right? So this is how you can find the value of the answer for the number 2. Continue to the number 3, sketch graph acceleration versus t. So to sketch graph acceleration versus t, so this is second and this is meter per second square. So meaning here the value of the acceleration is acceleration is constant, because a 9.81 meter per second square. So the direction a is always to the downward, so we have a negative a here. So the graph is constant, is here is equal to 9.81 meter per second square. So we have a negative graph here, right? Okay, so continue to the number 4. Time of flight. To calculate the time of flight here, so we can use the equation sy is equal to uyt plus half gt square, right? This is how to get the value of the time of flight t here. So because the direction you refer to the y, vertical motion here, the displacement here, the height is a negative 17 here. So initial u, because start from the 40 direction, only the horizontal, meaning uy, this is equal to 0, and we have a negative half g here, constant 9.81, and you can find the value of the t here, t. So if you have the calculator, the value of the t is equal to, so I write here t is equal to 3.78 second, right? Okay, t 3.78 second. So now what is the last is range. So to calculate the range, you can use the equation range, or r is equal to u x t. T is time of flight. This is answer from number 4. So u is always constant, 40 meter per second, and the t is answer number 4, 3.78. so you can find the value of the range. So meaning here, this is let's say this is so I write here, right? So this is the path of the stone. So this is the range here. So r, this is the range. So we have a 151.2 meter. So this is value of the r here, 151.2 meter. Okay, that's all. Thank you.